A.Zakharov from Moscow Institute of Theoretical and Experimental Physics. He continued to discuss supermassive black holes.
This presentation with some song, the famous singer. She was very popular 40, 30 years ago. But also some of these claims are quite scientific ones, so they are quite correct. We have only doubt that is no one has even seen, but I think it's no one has even been there in black holes. So, but seriously speaking, that is title of my talk, that is outline of talk. I will stress, consideration at shadow and also some observational features of Reisner-Nernst black hole, also probably the galactic center, also trajectory of bright stars. So, but you know, usually there are no significant prize for astronomers except some exclusive cases. It's references, it's also references, but very often people accept their skepticism in respect of black hole concept. A couple of years ago, it was published in an article in famous Nature magazine, so black holes do not exist. So, but this concept was introduced by the Reverend John Mitchell. So, but the idea is very simple in the framework of Newtonian theory. It's if its density is like density of solar density or Earth density, but if radius is in 5 times larger, we have, escape velocity is the speed of light. In this case, this object will be so-called dark stars. What about Crawford prize? Around 1 year ago, two observers from the United States and Germany were awarded is Crawford Prize, and from form of Swedish Academy of Sciences established Crawford Prize for astronomers. Once per 3 years, some famous astronomers were awarded this prize. And these two people, Andrea Ghez and Reinhard Genzel, were awarded for their investigation of stars orbiting the galactic center, indicating the presence of supermassive black hole. That is formal declaration, formal claim of Swedish Academy of Sciences. Who are these people? That is portrait of one. It's another person. She is a leader of observer with a Keck telescope. But it's a few words about this prize because somebody did not know, and people. So, for instance, some mathematician is probably this audience. People know Edward Wheaton and Maxim Kantsevich. He is a famous mathematician. Now he works in France. And Rashid Shunayev. He was awarded also with this prize 5 years ago. Who are other people among astronomers? Sandwich is very famous, and also I will skip details, but it's also Gahn, Peebles, and Rees were awarded with this prize. And one of the first recipients of this prize was Vladimir Igorevich Arnold, famous Soviet mathematician, Soviet-Russian mathematician. And but also I'd like to mention that these two groups of people quoted our paper about consideration of some limits on black hole model from observation of trajectory of bright stars. That is this quoted, this citation was listed here, and also in this review written by Reinhard Genzel and Stefan Gillison, they quoted our paper. It's also, it's also they received this diploma about one of the most cited paper in New Astronomy. So that is the list of history, but I don't pass through details of this history, but I would like to stress insight of John Archibald Wheeler. So because all people know, that is to form black holes we need infinite time. All that is a deformation of spectral line. 60 degrees, 80 degrees, 85 degrees. Here you see periods of extra peaks. But observer is located near equatorial plane. 88 degrees, 90 degrees, equatorial plane. But it's also a different emission region. It's 2, it's blue, it's 2, 5, and 10 Schwarzschild radii. This opportunity with significant charge considered with other authors has to be ruled out at 9 sigma confidence level, at very high confidence level with negative charge. But I mean, light bending due to very strong deflection of light near the black hole, because people cannot be hidden behind the black hole. So it's very often people are repeating this picture, even in presentations. So, but you know why it's wrong. Student Chris Cunningham, 40 years ago, he published shape of trajectory. So elliptical curve will be visible like this distorted curve due to deflection of light. So, so just for better illustration, we could calculate that is accretion disk. That is some kind of, let us say, redshift map. This part of accretion disk has to be blue, but it is red. So, but if we introduce some emission function that is intensity, it has to be, I mean, it's blue. If we substitute Yukawa theory, Yukawa gravity theory for the galactic center, instead of Newtonian theory, we could put limit for delta and lambda parameters for Yukawa theory, because informally, for Yukawa theory, high chi-square is better than for Newtonian case. So in this case, our conclusion that we need future observations, more precise observations, to put other limits, or really to clarify these claims. In millimeter sub-millimeter band could detect traces, images of black holes, shape of images, important information about black hole parameters, trajectory of bright stars is also important tool to evaluate parameters. Trajectory of bright stars or bright spots around black hole could give constraints on alternative theories of gravity, including some fundamental parameters, so which do not depend on parameters of system, and significant tidal charge suggested for the galactic center is excluded by observation with very high confidence level. And so, main conclusion probably for panel discussion, like initial claim. Perhaps black hole model is not the best and the not final one, but it's working. Alternative theories or models have to explain the observational data as well to be adopted as realistic one. Criticism has to be constructive. Thanks.